Welcome everybody. Uh, okay, so we got quite a few brave souls who made it in to the randomly assigned room through the biting cold. So well done. I see we got a few people online as well who found it too challenging, which I understand. So what we're going to talk about today is Milestone 2, and we're going to do a walkthrough of how to get going on it. So you haven't had a lecture on this yet. I'll post the lecture notes right after this tutorial. So some parts of this I'll kind of try to slow down and explain to you, what are we doing? Because this kind of goes together with a lecture that you haven't had yet about how the graphics package we're using works. But it should still be pretty understandable. Just ask me if you kind of are wondering, hey, what is that API call? Okay, so Milestone 2 is all about visualizing a map, interacting with it. So how are you going to get going on it? Sometimes students find starting on it it's actually not that hard a milestone. It's kind of fun, but getting started, students sometimes find a bit overwhelming. So what do? Download the M2 handout, read it. How many people have looked at the M2 handout? Okay, a couple. Okay, so go and read that handout. You're not going to be able to code this without reading it. It's not as long as the M1 handout, so that's a bonus. There's a walkthrough in the 4th section of that, so read that, follow it. You're visualizing a map, so you need to use graphics. There's a quick start guide on an easy to use graphics layer that we've written for you. Basically, you're going to see this in lecture, but we're using a graphics package called GTK, which is used to build lots of Linux applications. It's a little complicated to use GTK, so we've written a layer above GTK that's pretty easy to use. You can do the whole of Milestone 2 just by using that layer. We call it EasyGL. If you want to, you can go under that layer. You can use anything you want from this quite full-featured toolkit called GTK, but you don't have to. But before you start going, read this EasyGL quick start guide, because you're drawing stuff on the screen, you're doing graphics, and if you haven't read how does a graphics library work, that's not an efficient way to develop. How many people have written graphics code before? So who in this room has written graphics code? So 3 people, yes. 1 person, maybe, not quite sure. It might have been graphics, might not. So, okay. So some people have done a little bit of graphics. Graphics is kind of fun, and it's not that hard to learn. So you should enjoy, hopefully you'll enjoy Milestone 2. Okay, you're going to modify main.cpp a little bit. In Milestone 1, it was all about the unit tests. In Milestone 2, you are actually making your main program, but you won't write much code in main.cpp. It's really just going to launch your graphics, and most of that code is going to be in your library again, libstreetmap. And you're going to implement a function called drawMap, which does exactly what it sounds like. It's your main drawing routine. Okay, so modifying your main function. So here's in main/source, you've got this main function. And who knows what this stuff is? You seen this before? Does that look familiar, or nobody's seen that before? That's how you pass arguments from the command line in C and C++. So if you want to, you can use this to basically have your program take arguments from the user. On the other hand, you don't have to. So you can just ignore this stuff if you want. But that's, for example, one way you could get the name of the map is to actually read, how do I get command line arguments using this? This basically says, here are the number of words the person typed, and here are those words. That's what that is giving you. So if you want to, you can use that, to have options when the program is started. First thing we're going to do is we're going to load a map. Okay, so we load the map with some path. We got that somehow. Maybe it came in from the end user typing it. You could also write this so that when your graphics are running, there's a button that lets people choose which map. So you could do that as well. But the way I'm doing it here in my main function is I say I'm going to load some map. I haven't told you how I got that name. Maybe it came from the command line. If it loads properly, that's great. Otherwise, I print an error message, and then I draw the map. Okay? So you have to somehow get a map name, maybe from the command line, maybe from the graphics, and then you're going to start drawing the map. And when we're done drawing the map, we're going to close map. Okay, why do you have to follow this sequence that you do load map, draw map, close map? Because we also do have unit tests, so it's hard to perfectly test a user interface. But we do have unit tests that will allow you to quickly sort of check a bunch of different maps, and we can use to run Valgrind on your program. So you do want to follow this convention of load, draw, close. Okay. Other than that, you can pretty much do anything you want. Okay. So your main is going to be pretty simple. Okay, it's not going to do very much. Your main logic is going to be in that draw map function. So our first goal is to just create an empty window. We want to bring the graphics up. Okay, so that's what we're going to try to do. And so this is that EasyGL library that I was talking about. And it will make these buttons for you. It will make a window for you. It gives you an area that you can draw in. So this whole area, you can draw whatever you want in. We're not drawing anything to start with. We just want to get a window up. Okay, so what do we have to do to make that happen? So this is now inside my libstreetmap again. That's where I should write this, because we can do a few things with unit tests. And if you wrote all of this inside of your main/source, then we can't unit test it. And we are going to unit test. Most of this is a help to you, that basically you can test your graphics with a whole bunch of maps easily by running EC297 exercise. In order to be able to do that, you have to write your draw map in libstreetmap/source. Okay? You can write it in whatever files you want. We don't care what the file name is. We don't care if you use 1 file or 20 files. Do anything you want. In this example, I haven't even said what the file name is. Doesn't matter. But let's say it's m2.cpp. So I'm going to include m2.h because I might have some functions that I export. So that was my choice. And in order to make use of the graphics package, I have to make these 2 includes. So at the top of any file that's going to do graphics, you're going to put these 2 include files in. Okay, and here's my draw map function. So let me walk through what this does. So it basically creates an object of type EasyGL, okay, in the EasyGL namespace. So remember, there's a standard namespace. We made a namespace for EasyGL. So in the EasyGL namespace, there's a class called application, and it's got an object or a type inside of it called settings. So that's what I'm asking for, just a type. And I made an object called settings. Okay, so I made an object called settings of this proper type for EasyGL. And then I'm going to set a few values in it. So, and this, you're pretty much just going to copy. Like whenever you want to get graphics going, there's a little bit of boilerplate to just make it work. So I'm going to say settings, and there's a value in it, like a member of that class called main UI resource, which is basically your window layout. I'm going to show you probably next week how you could actually change this if you want. But this is basically the layout of the windows. It's called a resource. We've already made one. It's checked into your, when you do EC297 init2, you're going to get some files put in your Git repo. Okay, so you're going to get these files will be put in your Git repo, and this file will be put in your Git repo. Okay, so that main.ui says what's the window layout. And then we set the window identifier. So we're basically just telling EasyGL inside this resource file, there's something called main window. That's the main thing that we want to be drawing on. Canvas identifier, that's another item that EasyGL needs to know. So main window is basically what's the name of the whole window, and main canvas is the part we're going to draw on. So we just tell it those names. And You can use all three of these lines unmodified. Okay, there's no real reason to change it. We already made this for you, and we tell EasyGL what we called the window and what we called the main drawing area. Okay, and then we basically say, okay, we're going to create an application object. So it's of type, in the EasyGL namespace, we have an application object. We're going to call it application. And its constructor takes one argument, which is this settings object that we just set up. Okay? So after we've gone through those first few lines, we basically created our graphics object. Okay? And then we make this call. There's a member function of this EasyGL application called run, which basically makes your window actually appear and pay attention to user input. It can take some arguments, which we're not going to use yet. Okay, so we can just set all of these to null. It takes 4 arguments, but it's legal to set them to null if we don't need to do anything with them yet. So we're just going to set them to null. Okay, so this just basically talks about what I just said. We set up the configuration of EasyGL, we created the application, and now we run the application. So this is an interesting function. This function does not return for a long time, okay? This basically passes control to the graphics. And as the person clicks on buttons and so on, the graphics are responding. So this, you're gonna basically sit on this, inside this subroutine for a long time, okay? Until the person hits a certain button that says, I'm done, go back to the main program. Okay, so that wasn't, if you've ever written graphics code, you can see often you'll find it takes a lot of code to actually get a window going. So this was not very much code, and it will get a window going. So let me go and show you this. Well, I guess our window's boring. I'm going to show you this in a demo in a second. It basically has a name. It has some buttons on the left. This was all created by that main.ui file. And these buttons let us pan, so we can move around the graphics, but we're not drawing anything interesting, so that's not super useful yet. We can zoom in, we can zoom out, we can fit everything in the window, and proceed is a special button that basically means return from that application.run. So if you hit proceed, we kind of leave this application.run and actually come back to the rest of the program. You could do something else. Okay, so we could be here for a long time. Person could be clicking on buttons, looking at stuff for a long time before you ever come back. All right, so let me go and demo that. Then I'm going to check if you're still with me. Let's see. Okay, everybody see that okay? Let's see, do you want the font bigger? Is this big enough or not? What do you think? Can you see it in the back there? You guys can? At the very back, can you see it? You have very good eyes. I can barely see it up here, so that's great. So I might try expanding this one more. Let me just take a look at this. Yeah, I guess that's 20-point font. Maybe I'll leave it at, maybe I will take it up one more. Okay, is that better or still, can you really see it at the back? Yeah, okay. So let me go and show you what we've got here. So this draw map minimal is basically just doing what I just showed you, okay? It sets up these variables, the settings object for EasyGL, creates the EasyGL application according to those settings, and then calls this EasyGL or this application.run. Okay, passes control to the graphics. And let's see what that's in. Okay, so if I go down to the very bottom here, my main program, yeah, maybe I'll show you my main program as well. Okay, here's my main program. So my main program actually takes in a map name from the command line. It has a default. This person doesn't type a map name. I use Toronto. And I load that map. And then I call this function drawMap2. And in drawMap2 is what I was just showing you. Okay. So drawMap2 doesn't do much. It's just a wrapper, calls the helper function. So the very first version of it, my graphics program is this one, drawMap minimal, which just opens this. Opens up the window, but doesn't do anything else. Okay, so let me build this. And I'm not running the unit test. I'm actually running my real program here. So I built release, and I'm going to run it, and let's see what it does. Okay, so it does what I said. Okay, so there's my program. Didn't take me many lines of code to get this going. On the other hand, it doesn't really meet the needs of Milestone 1, right? Does this look like Toronto to you? This is supposed to be the Toronto map. It looks like Toronto, maybe today, okay? So it's pretty cold. Nobody's doing anything. Nobody knows where the lecture is. That's Toronto today. Okay, if I hit proceed, I'm going to actually return from this application.run, and the rest of my program just closed the map and is done. So if I hit proceed, this is just going to end, and that's what happened. So that's my first shot at this. But this is what your first shot should be too. Just get the graphics up and running. Okay, so we did a demo of an empty window. Now let's try to do something a bit more interesting. But again, you always want to test little bits of functionality. So that's a milestone to get your graphics window going. Okay, so what do I need to do next? So I've still got all the same code I had before. This is just setting up my EasyGL application. But now I actually want to draw something. And let me show you where it's going to go. Basically, this drawing area here is set up as what we call the main canvas. You can draw anything you want there. So that's where you're going to draw your city. Okay, so what do I have to do that? I have to choose a coordinate system. So you don't generally want to use a graphics package that forces you to use some coordinate system. You'd prefer to choose your own. So EasyGL lets you choose your own coordinate system. So we create an object. It's in the EasyGL namespace. So it's called EasyGL rectangle. We're going to name it initial world. And it's basically 2 points, a lower left and an upper right on the screen. So we're saying the lower left corner of the screen is going to be at coordinates 0, 0. And the upper right corner of the screen is going to be at coordinates 1,000, 1,000. Nothing magic about this. I could choose any coordinate system I want. This is just one that we decided to use. Okay. Then we have to set up the drawing area. And it's mostly set up. We have to do a little bit more. So we say on this application object, we can call an add canvas, add a drawing area function. And we need to say what the name of the sub window is. And the name that we put in that main.ui layout is called main canvas. So just use that name. And then we have to give it the name of a function. This function knows how to draw our city. Okay, so that's an important function. And we tell it our initial coordinate system. So our coordinate system is this initial world that I just made. Okay, well, we go back here. So this initial world is the coordinate system that we just made, and we're connecting it to the drawing area. And we're also saying, what is the function that will be used, like the name of the function that we're going to use to draw this. So these two things, these two arguments we actually think about. The name here, name of that sub window main canvas, we're going to leave alone, because unless you go and edit that main.ui layout, that's the name we put in it. So you got to use that name. Okay. Let's see. Okay, so is everybody with me so far? Does this kind of make sense? this draw main canvas, so that is the name of a function. It's you can pass around the names of functions in C and C++, just like you can pass around the names, like you can pass around variables. Okay, so you can actually pass function objects too. That's what we're doing here. This is called a callback function. Does anybody know what a callback function is? You ever heard that term? Okay, so a callback function is something you may not have had used yet, but it's used heavily in programs that interact with people. So this is basically where we're passing the name, or more specifically, a pointer to this function. That's what this name turns into. It just turns into a pointer saying, where is this function in memory so that it can be called. We're basically passing a function name in because once we call application.run, it's going to actually need to redraw our graphics many times. As people zoom in, zoom out, cover the window, expose the window, shrink the window, whatever, it actually needs to redraw our graphics lots and lots of times, okay? And we don't want to actually write the code to manage that, or you don't want to write the code to manage that. So we wrote it once inside this application.run and a whole bunch of helper functions. But it can't know what you want to draw. It can know when the window's been resized. It can know when the person clicked zoom in or zoom out, but it can't possibly know what you want to draw. So the way that works is you tell it, this is the name of my function that will redraw. When you need a redraw, call that function, okay? You don't know what it does, don't worry about it. I'm just telling you, that's the name of, you're telling the graphics package, that is the name of my redraw function. Call it whenever you need a redraw. Does that make sense? Okay. So that draw callback is actually going to be your most important function. So, and we called it draw main canvas. Your draw callback has to have the right function signature. So it has to match what the graphics package expects. The graphics package expects you to pass it the name of a function that returns void, and that takes one parameter, which is, again, in the ECGL namespace, it's an object called renderer, and it's actually a pointer to it. Okay, so you're going to get passed your draw main canvas, which is a callback function that you write, is going to be passed this one argument, which is a pointer to a renderer object. A renderer object in EasyGL is an object that knows how to draw stuff. Okay, so you can use it to get at member functions to draw things. So we're just going to draw. So we're going to use this renderer, the pointer. So we can use the arrow notation to get at its member functions. It has a member function called draw rectangle. Draw rectangle takes a lower left coordinate, so XY coordinate, and an upper right XY coordinate. We're going to say lower left is 0, 0, upper right is 1,000, 1,000, and draw me a rectangle. We didn't say what the color is, so it'll be whatever the default color is, which happens to be gray. Okay. So you can change anything you want in here. I just made that up. I said, draw a rectangle. You cannot change how it is called. Okay, because the graphics package expects you to give it a callback function that works this way. Takes this renderer object and returns void. So you can give it any function you want as long as it obeys that. But you can't just make up something and say, I'll pass it, I don't know, I'll just pass it a function that takes an int. Okay, that won't work. It'll say that's not the right kind of function. I don't care what your function does, but I do care about how I call it. Does that make sense? Because if you're not with me, tell me, okay? And we'll go over this in lecture as well. So some of this, you're seeing for the first time, like what are all these coordinates? You're going to see them at least one more time. Okay, so after we do this, so draw rectangle draws an outline. And don't worry, if you're wondering, well, how do I figure out draw rectangle draws an outline? You read the EasyGL Quick Start Guide, and the header files for EasyGL are heavily commented. Like they describe, here are all the drawing calls you can make, etc. So you first read the Quick Start Guide, and then you look at the header file, because you don't have to memorize any of this stuff. Okay, so draw rectangle draws an outline, doesn't fill it in. And we said that we want it from the bottom left corner of 0, 0 to the top right corner of 1,000, 1,000. Now we asked for a coordinate. Does anybody remember what coordinate system we asked for? We actually chose our coordinate system. What did we ask for? Do you remember? What's on here should help. Well, let's go back and take a look at it. Okay, so the way we choose a coordinate system is we made this initial world variable and we passed it into when we added the canvas. Okay, so what is our coordinate system? There's only a few numbers on there. So somebody's got to have it. Shout it out. I don't want to have to go to Andrew. I know Andrew knows the answer, but somebody else has got to know. So what's the coordinate system we've chosen? Yeah, what do you think? Yeah, it is Cartesian, but what numbers? What's our lower left coordinate? What's our upper right? Yeah, what do you think? Yeah, so it's 0, 0 to 1,000, 1,000. Okay, and then we drew a rectangle from 0, 0 to 1,000, 1,000, 1,000. So we got this outline, which almost fills the graphics area. Basically, this window here, or sub window, is the area that you're drawing in when you went in your callback function. It's drawing on that canvas. These buttons are being managed automatically for you by EasyGL. So this is the part that you're drawing. Why doesn't it go? Why do you think it doesn't go all the way to the edge? It goes to the top, goes to the bottom, but it doesn't go all the way to the left, doesn't go all the way to the right. Is that actually invisible? Huh. Can you actually see that? On my screen, I can see it. Maybe the resolution is not high enough. Okay, I'm going to go to the demo because that is invisible to you as well, right? Okay, so let me go to the demo because this actually shows up on my screen, but I think the resolution is not high enough on this. All right, so let's bring this up. Okay, so this was my draw map minimal. Go down to the very bottom of this file. Okay, so my draw map minimal just opened the graphics window. I want to go a little further than that. I want to do this one. This one draws the outline. Okay, so not super interesting, but it's a little more interesting. Okay, so successfully build, and we run it again. All right, can you see that? Huh, that's really interesting. It's annoying. Huh. Okay, so on my screen, I see a line here and a line here. You know, so I have to take my word for it. And I don't know why that doesn't show up for you guys. Okay, it doesn't go all the way to the edge because I asked for a coordinate system that goes from 0, 0 to 1,000, 1,000, and my window's not square. Okay, so I get a little bit of extra real estate because EasyGL basically will adjust the coordinate system so that an X unit is the same distance on screen as a Y unit. So it doesn't want to distort your graphics. So you ask for 0, 0 to 1,000, 1,000, but it actually will just draw it a bit bigger. And let's see, I'm going to quickly see if I can change the, I'm going to quickly go and, it's always dangerous. Let's see. So my callback function is draw main canvas blank. Okay, so I'm going to set a color. Okay, let's set the color to, let's see. Let's set it to black. Okay, so 0 red, 0 green, 0 red. Okay, I'm going to set the line width to be make it pretty thick. Okay, we're going to see if this actually will be visible to you now. So I run that again. Okay, can you see that? Okay, so you also see it's not that hard to draw things. Okay, so the default color was kind of a gray, and the default width is 1 pixel wide, was now showing up on the screen. So I just made it black and thicker, and now you can see it. So you can see this doesn't go all the way to the edge because, again, this window is not square. Okay, so it gave me some extra real estate. This still will be at 0, 0. That'll be at 1,000, 1,000. It's just my X dimension. It's probably visible from about -500 to positive 1,500. Okay, and I can now zoom in and out and so on. So if I zoom out, this goes away. I can move it around with these buttons. I can just click and drag. If I had a mouse, I could click and drag. Let's see, I think I haven't used this one enough, so let's see. Yeah, so with a mouse, I can click and drag. Haven't done it with the touchpad. And zoom fit goes back to the, so these buttons basically are zooming in, zooming out, panning, getting it back to the window. If I hit proceed, all of this is in that application.run. So I've been inside that function now for a long time, because that function is basically figuring out what I'm clicking on, what am I doing, and whenever it has to, it calls my callback function. So now my callback function is always doing the same thing. You notice that my callback function just draws this rectangle from 0, 0 to 1,000, 1,000. It doesn't ask, did you zoom in, did you pan left, etc. What's happening is EasyGL is keeping track of how my drawing should be mapped to the screen. So as I zoom in and zoom out, it has something called the transformation matrix, which is how does my coordinate system map to the pixels of the screen? And it's updating that matrix. And so I don't have to do anything, right? I just keep drawing the same thing, and it shows up at the right zoom level and so on. So it's actually made my life a lot easier. I wrote 3 lines of code, and it kind of looks like I'm zooming in, I'm zooming out, but I'm not really doing much. I'm not doing much of anything in my code. I just redraw whatever I want. Yeah. Yeah. So you can query basically what are the boundaries of the what's called the world coordinate system. So that initial world that we set is your coordinate system, and by convention in graphics, that's usually called the world coordinates. So you can ask what are the bounds of the currently visible world coordinate, and you'll be told right now, for example, this was probably about -2,000. You know, -2,000, comma -1,000, and that's probably about +5,000, comma +3,000. So if you say, the function calls get visible world. If you called get visible world, it'll tell you that. And from that, you can say, okay, how much is visible? Am I zoomed in or am I zoomed out? Does that make sense? There are a couple of other functions, but that's the most kind of basic and probably the most useful one. Just tell me how much of my coordinate system is visible. If I zoom way in, well, let's get a corner of this thing. Okay, so now I'm zoomed way in. My this coordinate now might be, I don't know, 700, comma 700. Actually, no, this would be like -300, comma 700. And this might be, you know, +300, comma 1,200. Does that make sense? Okay. And when I hit proceed, this is going to return from application.run, and my program could keep going. My program doesn't do anything very useful after this. It shuts the map, closes the map, and it ends. Okay, so that was that. Okay, so we just demoed that. Okay, so our next goal is to actually draw the intersections. And you're probably going to have trouble doing this, but basically, I've made a little structure for my intersection data. So I've got a name and a position in latitude and longitude for every an intersection. I'm going to make a vector. So I actually made a global variable called intersections. It's of type this intersection data. So I'm going to basically put in my vector. What's the location of every intersection? What's its name? And in my draw map, I'm going to use this to draw. Okay, so I'm just going to show you what that code looks like. So the first thing I'm going to do is I'm going to make my vector have space for every single intersection. Right? Remember, that makes the vector, this resize makes the vector that size. So it's going to have an entry for every single intersection after I call that. Okay. And then I'm going to go through, and for every single intersection in my city, so from 0 to get num intersections, I'm going to store the position of that intersection as just whatever I got by calling the streets database API. And I'm going to store the name of that intersection as whatever I got by calling the streets database API. So, I didn't really have to store this in a global variable because I could just ask for it from the streets database API whenever I wanted. But in case I'm going to create more data for intersections, I've just started by making my own data structure and loading it up. Okay. So I've done some setup here where I've loaded things in, and then I'm going to call this application.run. Okay, so application.run is again what invokes the graphics. So in order to actually draw something, my callback has to draw it. And remember, we hooked up a function that we called draw main canvas that took a renderer object. And before, it just drew a rectangle. Okay, so it drew this rectangle from 0, 0 to 1,000, 1,000. How are we going to draw this? You probably can't do this yet because you haven't actually had a lecture on it. So I'm just going to show you. Well, what do you think? How would I draw the intersections? Like, what's the basic thing? Am I going to loop through the intersections, you think? So yeah, I'm going to have a loop, go through all the intersections. I just loaded this data structure with their position and latitude and longitude. So I could just loop through. I could say, well, where are you in terms of latitude and longitude? And I'm actually going to draw, I'm going to use a function called fill rectangle. Fill rectangle just fills in the box. Draw rectangle draws the outline. So what am I doing here? So I'm just looping through all the intersections. So that's pretty basic. For every one of them, I've already stored what is its longitude and what is its latitude in this intersection data. And I just got that by asking streets database. So again, I don't necessarily have to store it because I could have just asked streets database again. But I decided to do that. I say my width is equal to 10 units and my height and width are the same. And then I say I want use my renderer object. That renderer object is the way I'm going to access all these EasyGL drawing functions. And that's why it's always passed in to my callback function so I can use it. So I'm going to call a member function that, again, if you look in the EasyGL header file and the quick start guide, it's going to tell you about this. There's a function called fill rectangle. It takes a lower left point and an upper right point, and it's going to draw a rectangle in between those. So I want to draw a rectangle from the latitude and longitude of this intersection. And which I've just stored in X and Y, to 10 units to the right and 10 units up. Okay, so I'm basically drawing every intersection at its latitude and longitude. And that's the lower left corner of the rectangle, and the upper right is just 10 units away. So what do you think? How's this going to work? Is it going to work well? Is it going to work not well? It's always good to hypothesize. So in the back there, what do you think? Yeah, so this is not going to work super well because I'm directly drawing latitude and longitude, which actually will distort my map. Okay, so you're actually have seen a flaw immediately. We really should project this to X and Y, which is in meters, because then we won't get a distorted map. So it's not going to work all that well. Any other problems? Okay, so let's run it. So, okay, so let me bring up the demo again. Let's see. Okay, so I'm just going to go down to the bottom and so all I'm doing is commenting out my previous setup code, and now I'm replacing it by the code I just showed you. So nothing magic about what I'm doing, but I can't type that fast. So we're just going to bring up that code. Okay, so I compiled it, I run it. Okay, and you can actually see something. Yay. Okay, so you can actually kind of faintly see the outline of my box from 0, 0 to 1,000, 1,000. And where are my intersections? Does this look like Toronto? Because the map I'm trying to draw is Toronto. Does not look like Toronto. Where did all my intersections go? What do you think? Yeah, so Toronto's latitude and longitude doesn't vary that much. Okay, so Toronto's latitude and longitude go from, I don't know, something like latitude 43 to latitude 44 maybe, or 43 to 43 and a half. Like a line of latitude is a lot. It's like 112 kilometers or something like that. Maybe it's 112 miles, but it's big. And a line of longitude at our this latitude is, you know, not quite as far apart, but maybe it's like 70 or 80 kilometers. So the numbers aren't going to be very different. And we said our coordinate system is from 0, 0 to 1,000, 1,000. So that doesn't really match what we're drawing. Our latitude and longitude are basically numbers that are, well, latitudes from maybe 43 to 44. So it's actually here. Okay, this dot are all the intersections in Toronto. They're all pretty much on top of each other. And we also said they're 10, draw them all 10 units in size. So we put them all in a really small area with, you know, a rectangle that's like 10 by 10. They're pretty much on top of each other. So that is Toronto. That's our visualization. What do you think? Can you find your way around? Yeah. So it's not great. So we have to fix this. Okay, so yeah, so that is where all our intersections are. Okay, so you actually flagged another problem, which is that drawing latitude and longitude directly is not best practice, but I'm going to ignore that one for now because I've got even bigger problems to fix, which are, I just mentioned this. So our latitude and longitude are, let's take latitude because I remember it better. It's from maybe 43 to 44. Doesn't match our coordinate system. So we need to change our coordinate system to match this. Does that make sense? Should I hard code, you know, the coordinate system should, instead of going from 0, 0 to 1,000, 1,000, it goes from, let's take the y part. Should the y part go from 43 to 44? Just hard code that. What do you think? It could do that. It'll work for Toronto. Is it going to work for any other place in the world? No. So as soon as your TA changes the map, it's not going to work. Sadness will result, recriminations, not good, okay? What can we do that's better? So we need to figure out a better coordinate system than this. We've hard-coded 0, 0 to 1,000, 1,000, which is totally useless. We're not going to hard-code Toronto. What are we going to do to get the right coordinate system to set? What do you think? So you're asked any city in the world, draw it. How could I figure out what coordinate system to set for Toronto, but also Beijing and Tehran and so on? What could I do? What do you think? Yeah, so I'm just going to repeat that. Basically, the suggestion is we'll just go through the whole city, go through, say, all the street segments, find the minimum latitude, the maximum latitude, the minimum longitude, the maximum longitude. Let's set that as the coordinate system, and that'll work fine. And you're worried that would be inefficient. Do we have to do that very often, or can we just do it once? We can just do that once. We can do that in like load map, for example, that we could set, load map could go through our city. It could store that data for us. We could use it when we're setting up our coordinate system. It's an order n computation, which in load map is like nothing. Like, don't worry about it. Yeah. It's not directly speed tested, except your TA watches it. It's called a lot as you're doing panning and zooming. Like every button click that causes a redraw is calling your draw map. So it affects the responsiveness of your program. So you would like you'd like your redraw routine, this one, draw main canvas or whatever you call it. You don't have to call it this name, but you want this redraw routine to be as fast as you can make it because it's basically your frame rate. And there's actually a wild difference. We'll have some teams will have one where it takes perhaps several seconds. And like you're sitting, actually there are occasional ones that go off the rails where it just takes minutes, which, you have time for a long conversation amongst the team and with the TA about why the redraw takes several minutes. You'll have others that take seconds, which is kind of painful. And you'll have others more commonly can redraw a few times a second. And you get some teams who just, it's smooth. So yeah, so you try to make it fast. So yeah, you described exactly what to do. We're going to find this max lat, min lat, max long, min long. How are we going to do this? Tell me what would the code look like? Yeah, so put it in a helper function, and we're going to call it load map. That would be a good place to put this, and just store the data somewhere. What should we set max lat to? So this is basically a standard way to find the max and min. So it's not too hard. Basically, I need to initialize all these variables, and then I'm going to loop through all the intersections, and I'm going to update them. And at the end, I've got my answer. So what should I initialize max lat to? What do you think? What do you think? No, we don't give you one. So you can write one, but we don't give you one actually. So, so you have to write it. So what would you? But this snippet of code will do it if you fill it in. So and all four of these are going to be pretty similar. So for max lat, what should you initialize it to, given the structure I created here? What do you think? Yeah, so, but this is basically, there's a couple ways you can do this. I could set the max lat to be the latitude of the first intersection. That's one way I could do it. And then loop through all the other ones, seeing if they're bigger. Okay. I didn't do it that way. Another way I could do it is I could set the max lat to just be some small number. So I could set it to be equal to, negative 90, which is the South Pole. Or I could even set it to be negative 10,000, but should probably use a defined constant. And then I loop through. And what should I do here? What should max lat be updated to? Because I should check it against every single intersection. So I should take the maximum of this intersection's latitude and whatever I had up here. And all four of these are done basically the same way. Okay. So this one basically uses the technique of, okay, set it to the first point, and then go through and update for all the other ones. Okay, so the max lat is just the maximum of what I have right now and the latitude of the intersection I'm looking at. And you just do the same kind of thing for all of these. Technically, I'm wasting a little bit of CPU here. Given the way I initialize this, I could actually start at ID 1 because I start off by initializing everything to ID 0. Does that make sense? So standard technique to find the max and min of a sequence of numbers. Okay, so once I've done this, I'm just going to make a new initial world. My initial world now is not hard-coded. It's not 0, 0 to 1,000, 1,000. It's my minimum longitude, minimum latitude, because longitude I'm using is X, latitude is Y, maximum latitude, maximum longitude, or longitude, latitude. Connect them up. So when I create my canvas, I say what the initial world is, and notice I've changed my redraw function. So we're going to use a slightly smarter redraw function now. And let's see. So, and this is what we're going to get. So why do you think we get this? I'll demo it in a second. Actually, I'll demo it while you think about it. Think about why we got that. And okay, so let me exit this one. Actually, I won't quite demo it yet. Why do you think we got this? It's all black now. So we used to have like our intersections off in a little corner here. We don't have that anymore, but we just got this black rectangle. Why do you think that is? So we set the coordinate system so that it spans the correct latitude and longitude. We draw our intersections, Also in latitude and longitude. Seems like it should work, but we got this. What happened? How big are we drawing the intersections? Yeah, what do you think? Yeah, so we're drawing our our fill rect is also, it's in world coordinates. So the lower left is the latitude and longitude. That's what we're using right now. And the upper right was shifted by 10 units to the right and 10 units up. That's 10 lines of latitude and 10 lines of longitude. That is bigger than the whole city of Toronto by actually quite a bit. So every single rectangle we're drawing is enormous in our new coordinate system. So of course they're all on top of each other and we just see nothing. Okay, so they're way too big. Okay, so so if you play around with it, and I did, you find that if you set the width and height to about 0.001, so a thousandth of a line of latitude, thousandth of a line of longitude, that is more appropriate. The intersections now don't draw on top of each other. Should I change this based on the zoom level? What do you think? So this one's kind of a judgment call. If I don't change it, it means my intersections will get bigger as I zoom in, and maybe that's fine, right? Maybe that makes sense because I'm not going to see nearly as many of them on the screen. On the other hand, you might say, yeah, I don't know. I don't like them getting really big, no matter how much I zoom in which case you would have to change them based on the zoom level. But yeah, this one is a judgment call. It won't look bad if I don't change it. And it's easier not to change it, so I'd probably do that to start. So if I do this, this is kind of, I'm going to darken this up after the lecture. This looks like Toronto. Let me basically go and show you this in a demo. Okay, so let's run this. All right, that looks a bit better. Okay, so does that look like Toronto now? Like kind of, right? I'm only drawing the intersections. I'm not drawing the streets. So it's an unusual way to draw a city. But you always want to do agile development, get something going and gradually make it better. So the intersections are basically the right positions. They fill my screen, so my coordinate system looks reasonable. I'm now drawing them at a much more appropriate size. So they're all on top of each other. Just drawing the default colors. Maybe I should change the color. Anything else about this? So, and let me show you that all the zooming and everything works. And you can see as I zoom in, the intersections are getting bigger. So that's kind of the choice we've made. I could change that if I wanted. I could ask what's the zoom level and change it, but it's not a crazy choice because as I zoom in, I won't see as many things anyway. So maybe it's reasonable. Okay, if I hit proceed, we're done with that. Okay, so let's see. Okay, so you guys already told me. Why don't you, two of you told me, why don't you repeat what's wrong with this? So it's still not correct. It's better, but Toronto, it looks distorted. And the reason it's distorted is I'm drawing latitude and longitude. And the distance between lines of latitude is the same everywhere on Earth, but the distance between lines of longitude changes. As you get further north or south, the lines of longitude get closer together. So we should never directly draw latitude or longitude. Should use the projection formula that's given to you in Milestone 1 to convert it to X and Y, positions on the surface of the Earth, and then draw that. Does that make sense? I have two options. Okay, we can stop there, or I can show you how to convert this to X and Y. What would you guys prefer? Because we're actually out of time for this tutorial, although I have the room for another hour. So what would you prefer? Do you want to just keep going? Okay, so keep going for a little while. Okay, so we should project latitude and longitude to Cartesian X and Y. Okay, the big benefit is you don't distort your map. So you have to do this. The TAs are watching for this. There are some fraction of students who just, even though we tell them this and show them the sample code in the tutorial, they won't do this. So your TAs are for sure going to check this. You take a really far north or really far south map, it's really obvious that it's distorted. So don't draw lat long, draw Cartesian XY. If you look at the M1 handout, it gives you the formulas for this. They're not very complicated. You need to get the average latitude of the map. Okay, so you can't perfectly draw a spherical surface on a two-dimensional, on a flat screen, but it's pretty close for something the size of a city. Okay, there's not a lot of distortion. You convert from latitude and longitude to X and Y, and you use the average latitude of the whole map. So just like we calculated the max and min longitude, you can easily in your load map calculate the average latitude. Okay. Don't scatter the code to do the conversion throughout your milestone 2. Make sure you make helper functions. Okay, so these would be possible helper functions. There's lots of other ways you could make these. You could convert a whole latitude and longitude together, or you can convert the X and convert the Y. But don't scatter the calculations all over the place. Make a function, the helper function, and call it. And in some cases, it can be useful to go the other way too. Okay, this is the one you, let's see, this is the one you for sure need, these two, go from latitude and longitude to Cartesian X, Y. In some cases, you might find it useful to go the other way too. But you might not. The other way might not be necessary. Okay, so now maybe you see why did we create that intersections vector? So remember we made this global variable intersections? And we used to just store the latitude and longitude in it, which seemed kind of pointless. You could just ask for it anyway. Now we're going to do a little more work. We're going to convert the longitude to X. We're going to convert the latitude to Y. This function is going to need the average latitude, this X from ln, but we'll just compute that in load map and so that it's available. Does that make sense? The other thing you get is the units are now actually a lot more understandable. These X and Y are in meters. So you could choose, like I said, my width is 100 and my height is 100 for the way I'm going to draw my intersections. And they're much more understandable units. They are meters. So now I'm going to fill a rectangle from XY to, well, from the projected location of my intersection, XY, to over by width and up by height, where width and height are 100 meters. Does this make sense? So choosing a coordinate system that has physical meaning makes your life a lot easier too. So the XY is in meters. I can now think about how big do I want to draw an intersection? 100 by 100 meters seems kind of reasonable. Okay, anything else I need to change? What else do I need to change? So I'm drawing now in XY in meters. Okay, that's what I just changed. If I go back here, look at this quickly. There's a big change in what I draw. Okay, these XY are coming from these calculations, which are now projected on the surface of the Earth in meters. Okay, so do I need to change anything here? Okay, I'm going to change the name of my my callback function, just so that I've got a better one, right? That does the calculation I just showed you. Anything else I need to change? So what do you think? Yeah, so your coordinate system has to match your drawing. So this initial world is still saying, let's use minimum longitude to maximum longitude, minimum lat to maximum lat. So for Toronto, the min lat to max lat is again maybe 43 to 44. Makes no sense now that I'm drawing in meters on the surface of the Earth. I need to calculate new bounds. Okay, so I have these handy conversion functions. I'll convert my minimum longitude to a minimum X. I'll convert my maximum longitude to a maximum X, and so on. Set that as my world. And it's probably hard to see. It's kind of faint. But basically, the projection now, Toronto doesn't look stretched. Okay, Toronto was too wide and not tall enough. And let me do, so this is what they look like side by side. This is kind of a bad color, sorry. This is the old one, too wide, not tall enough. This is the new one. Let me show you a quick demo of it. And that'll make it hopefully more clear still. Okay, and all right. So that hopefully looks more like Toronto to you. So let's zoom in. Yeah, so that is the corrected projection. It looks better. All right. All right. And so that's it for today's tutorial. I'll repeat it for the people who just arrived. We'll go through, after reading week, we'll go through another half of this tutorial where we talk about how to handle mouse clicks, and we'll be talking about this in lecture as well. So the next few lectures and the next couple lectures of the next tutorial will be about more about graphics. Any questions on what we just went over? I guess one last thing I'll say is I'm showing you how to draw intersections to get going. I don't think drawing the intersections is the best way to draw a city. You could choose to draw the intersections, or you might choose not to draw them at all. You really want to see the streets. You want to see the buildings, the parks. That's really what makes a map look more intuitive. So just because I showed you intersections doesn't mean that you have to draw intersections. But basically the techniques are very similar, right? We're converting we have to pick a coordinate system. We have to convert to Cartesian X, Y, and we have to draw things within our coordinate system. You do it all in a callback function, which means that it'll be redrawn whenever the graphics needs it to be redrawn. All the panning, the zooming, etc., will all be handled for you. Does that make sense? Get something simple working, and then gradually iterate on it. So you want to add in features a little bit at a time, see how it's going. And yeah, you've got quite a while for Milestone 2, but don't leave it to the last minute. It can be pretty fun if you spread it out over time, and it can be pretty stressful if you go, maybe I only need like 1 day to do this. That's not a good idea. Okay, so I'm going to stop recording and repeat this for those who just arrived.